Welcome to 60th lecture on the course of Industrial Engineering and Operations Research. Now, in this module, we are studying inventory models, and this is the fourth lecture on the probabilistic inventory models. We are mostly following the book of Taha for this portion, and today we will touch upon on a last topic in that category, that is multi-period model. We will not go in too much detail, but I will just provide a type of exposure to you, because probabilistic inventory modeling may look a new topic to most of you, and it involves probability. So, therefore, it is better to understand it in easier way. So, we will not go in too much depth, but we will give proper exposure. So, we talked about single period models, in which, like suppose one example is newsboy problem or news vendor problem, in which many copies of newspaper are purchased in the morning and then they are sold, and decision has to be taken for one single period, that what should I do on Tuesday morning. Okay. So, in the multi-period model, it is in contrast to single period model, it is used for inventory systems where ordering, holding and demand occur over multiple periods, okay, of this for the same item. Newspaper also, it is single period, but of course, it is repetitive. Tuesday newspaper is different, Wednesday newspaper is different. But here what happens, that I can carry over something. So, I will give some example to understand it. Unlike single period models, these allow for inventory carryover between periods. In multi-period model, no setup cost is assumed. Additionally, the model allows backlog of demand and assumes a zero delivery lag. So, setup cost is not involved. It further assumes that the demand D in any period is described by a stationary probability density function, PDF is FT. So, that means demand is probabilistic, that is why it is a probabilistic model, and that density function of that demand is FD. Okay. So, you can say that if I multiply FD by DD, then it will give corresponding probability, that means everything is probabilistic. Okay. Example is that in online platforms such as Amazon and Flipkart, there is no setup cost involved in stocking or reordering digital goods. We can do that type of thing, and orders that cannot be fulfilled immediately are queued and delivered when available. So, that means there is no further setup cost. It is, back orders are delivered later on, and downloads are instant once available. That means as soon as something is available, then it will be immediately downloaded. So, that is why we say zero delivery lag. Now, say some popular e-books demand stays statistically consistent over time. So, therefore, in those situations we can say that FD is same for all periods. Now, what is the main thing in a multi-period model? In multi-period model, we consider the discounted value of money. If we take some alpha which is less than 1 is the discount factor per period, we can take that some alpha discount factor can be defined. Then an amount of rupees A which will be available in periods from now has a present value of alpha to the power n A. Okay. So, that is what that it is you can sell later on also, but that its value will be reduced. Okay. Suppose you have got an order of 100 units now, but you could not do and you did it in second month, maybe you can multiply by some factor 0.9 and you can say its value is that 100 into 0.9, like that we can do that. Suppose that the inventory situation encompasses n period, that unfilled demand can be backlogged exactly one period, then you define if phi xi is the maximum expected profit for periods I, and I is equal to maybe for periods I and I keep changing from say 1 to n like that, and given that xi is the amount in hand before an order is placed in period I. So, that means xi is the amount in hand. Assuming that C means cost per unit and revenue generated means price per unit, or the cost and revenue per profit, they are indicated by C and R. The inventory situation can be formulated like that. This is, we just are defining this thing, but main thing is these are the equations. If high xi is equal to maximum yi means which we should order greater than xi, and this is minus cyi rd. So, we would see that each component we have written, okay, probability distribution, just like in single period model, those terms we have written. You can understand each and every term one by one if you see carefully. Say for example, I might have xi item was already there, xi number of units was already there, and I ordered yi. So, therefore, yi minus xi effectively has been ordered, because yi is the total stock. Okay. So, yi minus xi is the extra which ordered, and for that I have to pay the cost. So, this will be cyi minus xi, that becomes minus cyi xi. Similarly, this is profit and holding cost and all those type of things, you can know that. The value of xi may be negative because unfilled demand is backlogged. So, it is need not be the case that xi is always positive, xi can be negative also. In that case, there is a no extra unit available to S, rather it is backlogged. Okay. So, in that case, yi minus xi will be more than yi and the cost will increase. Okay. Then the quantity alpha r d minus yi in the second integral, in this integral, is included because d minus yi is the unfilled demand in period I. So, suppose in the period I could not fulfill that demand because demand was d, but I had in stock only total yi. So, d minus y is the unfilled demand, and it will be, it would have generated this much revenue all d minus yi, but this will not be available, this will be available me in the next period, that is I plus 1. So, therefore, I am discounting it and I am multiplying it by alpha r. Okay. So, this way these type of things have been written. The problem can be solved recursively. For the case where the number of periods is infinite, the recursive equation reduces to, we can write like that, where x and y are the inventory levels for each period before and after an order is received respectively. So, optimum value of y can be determined from the necessary condition, that is del, and you take the derivative with respect to s and we give the derivative with respect to s. So, following Leibniz rule, we get this type of condition. The value of del f y minus d by del y is determined as follows. If there are beta which is greater than 0 more units on hand at the start of the next period, then the profit for the next period will increase by c beta. Okay. So, y minus d is something you can say the excess quantity, and this you have to differentiate with respect to y. So, therefore, it will give answer as c. So, this because this much less has to be ordered. So, this implies that del f y minus d by del y is equal to c, then the necessary condition becomes this, and therefore, the optimum inventory level y is thus determined from this, because from here you can put that y optimum, okay, because it is 0 condition. So, you can put y is equal to y optimum, and 0 y star f d d d is equal to this much. So, this type of expression has come, and the optimal inventory policy for each period given its entering inventory level x is thus given as, if x is smaller than y star, then order y star minus x. If x is greater than y star, then do not order. So, this type of thing is there, okay, but you know that since integrations etc. are involved. So, therefore, problem may take some time. I am not giving any example, okay, just concluding it here, and rather I will now solve very simple problems on the probabilistic inventory, because it should not happen that seeing the complicated expressions, okay, you will even forget the basic things. So, we will do that in a very basic way, and we will do that. So, mostly they are based on single period model, and it is something like that, News-Wendel problems. Okay. Say for example, first problem is that a shopkeeper is selling umbrellas. Each umbrella costs rupees 100 and is sold for rupees 150. That means you earn 50 rupee profit. Any unsold umbrella is wasted. Suppose you don't, so there is no salvage value. You lose basically 50 that 100 rupee rather. The demand is normally distributed with mean of 200 units and standard deviation is equal to 50 units. So, demand has been given, it is normally distributed like this type of thing. Okay, 200 unit may be here, mean, and this is like this here, maximum is 200, but there are this one 50 units. So, the question is that how should I find out that how many things I have to order. So, we remember that there is one formula that FQ star, that means total probability at this one should be equal to CS divided by CS plus C0. It is simple, and CS is basically the shortage cost. That means, if you do not have that, so shortage cost you are losing 50 rupee profit. So, therefore, shortage cost is 50 rupee, and this is the cost of overaging. That means, if you have purchased the excess one, so that means on each umbrella you are losing 100 rupee. So, therefore, we are putting CO is equal to 100. So, CS is known, CO is known. Therefore, we can find out CS by CS plus C0, which is also called critical ratio, and this becomes 50 divided by 150 is equal to 0.333. So, in a way that probability should be 0.333. So, corresponding to that, what is the Z that you can find out in Excel sheet? You can see norm inverse 0.33, and this gives in MS Excel as Z is equal to minus 0.43082. You can get it from tables also, normal distribution tables, but we got from Excel, and the order quantity is equal to, then in that case becomes 200 minus Z into standard deviation. So, therefore, you have to order 178.459. In fact, or you can say you order 178 umbrellas, then it will be optimum thing. So, here since the demand is normally distributed, and since here the basically the overage cost is actually too much, okay, so therefore, you do not want to take risk, and that is why you are ordering this. If FQ star would have been 0.5, suppose this critical ratio was 0.5, then you could have ordered only 200 units. Okay. If you just order 200 unit, then the 50% chances are that you will be stocked out, and 50% chances are that you will not get stocked out. So, that is why that you have to do order here. In this case, you have to order 178 umbrellas. Okay. So, that is one problem. Let us do the other problem. A product's demand during lead time is normally distributed with mean is equal to 500 units and standard deviation of 50 units. The company wants a 95% service level. Find out the safety stock. So, 95% service level, that means there should be 0.95 probability that you will not be stocked out. So, therefore, we say norms in V, norms inverse 0.95 give Z is equal to 1.64485. You can get this value from the tables also. So, we got Z is equal to here 1.64485. Now, mean is equal to 500, standard deviation is 50, service level 95% gives Z is equal to 1.645. So, therefore, how much safety stock should be kept? Mean is 500. So, safety stock will be Z into sigma, that means 1.645 into 50, that means 82.25, or you can put 82 units in the safety stock. Okay, that means above 500. So, something like 582. So, this is one problem. Okay. Now, let us see that we solve another problem. So, so since we have come 95% service level, let me just strengthen your concept about service level. In inventory management, service level refers to a company's ability to meet customer demand from available inventory. Okay. So, it is a critical metric for assessing how well a business fulfills orders promptly and accurately. If service level is high, that means your business can promptly fulfill the order, that means it can satisfy the customers. If service level is poor, then situation will be bad. So, a high service level means the company can consistently satisfy customer orders, while a low service level may lead to stock outs, back orders and lost sales. Okay. These type of situation. Stock outs means there is no stock. Back order means you have to supply in the next period. Okay. There will be backlog type thing. And lost sale means the customers may go away and you lost the sale. So, anyway, now a company has a reorder point policy. That means it decides that when the number of units reach certain number, then only it will order. Lead time is 5 days. Daily demand is normally distributed with mean 100 units, standard deviation of 10 units. The company wants a 90% service level. What is the reorder point? At what unit I should start reordering? So, here daily demand is mean is equal to 100, standard deviation is 10, lead time is 5 days, service level is 90%, that means probability is 0.9. So, corresponding to that Z is equal to 1.28. Okay. So, if you just say something, you can say that service level is, suppose this one. So, up to Z is equal to 1.28, you can say probably this area will be 90% of the total. Okay. So, that is what Z is equal to 1.8. So, you compute the total mean demand during lead period, lead time is 5. So, here with daily demand is 100. So, in 5 days means in lead time the amount has to be 500. So, therefore, it is 5 into 100 means 500. But you have to compute the standard deviation also during the lead time. So, per day standard deviation is 10 units. Okay. But you have to find out that 5 days standard deviation should be what? So, should it be 5 into 10, 50? No, this is wrong. In the means get added. Okay. Suppose mean demand was 100. So, we did for 5 periods 100 plus 100 plus 100 plus 100 plus 100 and we got 500. You see that much. But standard deviations are squared way they are added. Suppose you a sigma 1 square, sigma 3 square, sigma 4 square. That means variances are added, not the standard, this one. So, that means we have, suppose there are 5 periods. So, it will be under root 5 and sigma is constant in each period. So, under root 5a. So, sigma LT will be under root 5 into 10. Okay. This is one point you have to understand very carefully. So, therefore, it is 2.236 into 10, that means 22.36. And therefore, now reorder point will be what? Mean value plus Z times the standard deviation. So, mean was for 5 period, that means during lead period the mean was 500 and plus it will be 1.28 and multiplied by 22.36. So, therefore, it will be 500 plus 28.62 and this will become 528.62, that means 529 units. So, therefore, reorder point should be 529 units, that means as soon as the units reach 529, then you should place the order. So, that is called reorder point, okay, in terms of the units. Now, let us do that one more problem. A distributor stocks 600 units of a product. The demand during lead time is normally distributed with mean of 550 units, standard deviation of 40 units. What is the probability of a stock out? They are finding out just the probability of stock out. So, stock size is 600, that is given, but mean demand is 550 and standard deviation is 40. So, you can calculate the Z score for this value. I have 600, but the demand is 550. So, 600 minus 550, Z is equal to x minus mu divided by sigma. This is the standardization, this is the normalization, Z score. So, Z is equal to 600, x is 600, mu is equal to 550, standard deviation is 40. So, this becomes 50 by 40, this is 1.25. So, therefore, this Z becomes 1.25. So, probability of stock out will be P if probability of that Z is greater than 1.25, for Z greater than 1.25. So, this can be written 1 minus P, Z is smaller than 1.25, smaller or equal to 1.25. So, this P Z greater than 1.25 is equal to 1 minus P, Z is smaller or equal to 1.25. Now, from the Z table, or you know that using the Excel norms inverse function, P Z is smaller than 1.25 is equal to 0.8944. So, this value comes out to be 0.8944 and therefore, the probability of stock out will be 1 minus 0.8944 and this equals 0.1056 or in terms of the percentage 10.56%. So, therefore, the probability that someone will get stocked out is small only, it is 0.1056 because you mean was only 550 and you stocked 600 units. So, this is how that this can be done. Okay. Now, one last problem, a retailer wants to maintain a 95% fill rate. So, the standard deviation of demand during time is 20 units this time, okay, and the mean is 300. How much inventory should be stocked to maintain this fill rate? So, suppose we have to say fill rate 95%. So, although it is I somewhat approximate, I will tell you the difference between fill rate and stock out. It is something like stock out only, but there is a subtle difference. So, suppose we say mean 300, standard deviation is 20, fill rate 95% corresponds to Z is equal to 1.645, then inventory to stock will be mu plus Z into sigma, that means 300 plus 1.645 into 20, therefore, 300 plus 32.9 and this becomes 332.9 is equal to the 333 units, that means 333 units. So, this much should be stocked. Now, let us explain the difference between service level and fill rate. So, service level is basically the probability that no stock out occurs during the lead time. Okay. If there is no stock out, that probability, that it is not talking about how many units you are short. If you are short, then you are short. If you are not short, you are not. In other words, how often your inventory is sufficient to meet demand without running out. Okay. How often your inventory, suppose out of 100 times, 90 times stock out does not occur, then service level will be 0.9. So, mathematically service level alpha is equal to P probability that demand during lead time will be less than reorder point. Okay. So, that during the lead time you will not get stocked out. So, service level alpha is equal to the probability that demand during lead time is smaller or equal to the order point. Suppose service level is 95%, then in 95% of the cycle you will not stock out during lead time. So, it is basically cycle based, that means you calculate that out of several cycles how many times I got stocked out. Okay. Cycle means that one process that I ordered something, consume that thing, one cycle is complete, then I ordered again and consume that, another cycle. So, this service level is used to set safety stock, but it does not tell how much demand was lost when a stock out occurs. Okay. It is just that whether you fulfill the demand or not, but it is not telling about the quantity. So, in the fill rate, the proportion of total demand that is actually filled from stock on hand without delay. So, it tells about the quantity. So, fill rate beta can be defined in a very simple way. It is total units delivered from stock divided by the total demand. So, if the fill rate is 95%, then 95% of units requested by customers are delivered immediately from stock and 5% are back ordered or lost. So, that is maybe even for one cycle also that can be situation. So, it is not that there has to be lot of statistical data for other thing, because in service level, as I said, that suppose you did 100 cycles, out of 100 cycles in 90 cycles you were not stocked out. So, service level is 0.9, but here even in the one cycle, suppose you could satisfy 95% units you can fill from the reserve stock, only 5% you could not fill up, then it will be service level will be 90 that 0.95. So, it is unit based, it takes into account how much demand was unmet during stock outs. So, both concepts are little bit different, but sometimes when solving with the normal distribution, we almost take that fill rate like a service rate, like that we have done in this problem. Okay. Otherwise, you conceptually you understand. So, this is what we have done about that. So, anyway, so we have already solved some problems and we have told about that thing. So, we will conclude only at this level, and so that you can consolidate. We have covered sufficient material starting from the definition of industrial engineering and up to probabilistic inventory models. In between we have discussed so many topics: quality, production planning and control, aggregate planning, queuing theory, simplex method, part CPM and all those type of things. So, thank you very much for your kind attention. Thank you. Okay.